Good afternoon and welcome to today's CUTR Webcast on alternative fuels and public transportation. Today's webcast is the 9th in a series of webcasts that we began last October. We are here every other Thursday from noon to 1 p.m. Eastern Time, and we have presentations that vary in topic based on the wide array of research and projects performed here at CUTR every day. Today we have two exciting and informative presentations for you. Today's presenters are Steve Wright and Cecinio Kunkas. Before I turn the time over to our first presenter, we would like to find out more about who is in our audience today. So now is the time that we'll be asking you to participate in some poll questions. Our first poll question today is how many other people are viewing today's webcast with you? So please click on the circle next to the answer that best describes how many people are watching today with you. And we'll give you just a few seconds to complete that poll. Okay, I'm closing the polls and showing the results. It looks like the vast majority of you are watching the webcast alone today, so we do thank you for joining us. Our second question is, where are you located? And we have a variety of options here for you to choose your region of the country, or in the state of Florida, or even outside the U.S. So please choose the best response. Okay, thank you. I'll close the polls and show you the results so that you can see where our audience is coming from today. Our third poll question asks, which type of organization do you represent? It looks like most of you have answered the question, so we will go ahead and close this poll and show you the results. Looks like roughly 40% of you are from transit or TDM agencies, and you can see the rest of the results there. Our last poll question for you today is, how many other CUTR webcasts have you attended? Great, thank you. I'll go ahead and close the polls and show you the results. So it looks like we do have quite a few of you who have attended CUTR webcasts with us before, so we're definitely glad to have you return, and we're also glad to have our first-time viewers. Our next webcast, of course, will be on the 10th of March. So I'd like to talk to you a little bit today about our first speaker, and our first speaker today is Stephen Wright. Steve has been with CUTR since 2000, managing a program area that focuses on providing technical assistance and research to public transportation agencies. Most recently, Steve led the Tampa-Hillsborough County Expressway Authority as Executive Director, and in December 2010, he was named Interim Director here at the Center for Urban Transportation Research. Overall, Steve has nearly 30 years of national and international executive management experience in both the public and private sectors. So now I'm going to turn the time over to Steve to begin the presentation. Steve, are you there?
I am. Thank you very much, Jennifer, and greetings to everyone who have joined us today. I was noticing that several folks, this is their first CUTR webcast. So just a few minutes of background about the Center for Urban Transportation Research that is centered here at the University of South Florida. We were established by the Florida State Legislature in 1988, and typically We have about 100 active projects going on at any one time. That translates into about $8 million annually in our research. That's being conducted by student researchers and full-time research faculty, unlike many university transportation centers where their research for sponsors and clients is secondary to their teaching responsibilities. The researchers here at CUTR do the research on a full-time basis. And very briefly, Jennifer mentioned that we do have a fairly wide range of topics and expertise that we address that are housed here. In addition, we have two national centers that are housed within CUTR. One is the Center for Transit Research, or NECTAR. It's the only nationally certified university transportation center with a specific focus on public transportation. The other is the National Bus Rapid Transit Institute. CUTR has several programs. The first one, demand management, is the one that Phil Winters manages, and who works with Jennifer and is helping assist us in this webinar series. And you can see the other program areas there, everything from ITS and highway safety to mobility policy and transit training, technical assistance, and outreach. So I've got a couple of more questions for you that would help us frame this presentation and tailor it a little bit more to those that are participating. You see the question, and I see results are coming in. Are you currently operating any alternative transit vehicles? Okay, I see numbers are still coming in, so we'll just leave another second or two. And Jennifer, if we could go ahead and close the polls. It appears as though 3/4 of you are not, and 1/4 of you are. So, okay, that helps us a little bit. And for those of you who are operating alternative fueled vehicles, if you could just give us a sense of how many you are operating, that could be helpful as well. And it looks like for those of you, okay, Jennifer, we could close the poll. For those of you who are operating them, there seems to be a majority of you are operating 7 or more of them. Thank you very much. Again, for those of you who are operating alternatively fueled transit vehicles, if you could just indicate which fuels or drive systems you're using. And we're getting some responses on electric and natural gas. If we want to close those up, Jennifer, and share those results. Okay. And lastly, which of the alternative fuels listed would you be most likely to use in the future? That's of interest to us for several reasons. Okay, if we want to close those, please, Jennifer. So it appears to be a lot of interest in electric, and we're going to talk to that briefly today, both electric and hybrid electric. And again, I'd like to thank you all for joining us, I'll say this afternoon in the East Coast, and this morning for those of you west of here. And before I move on, I would like to acknowledge that much of the funding that we received in order to develop the model you're going to see later, and a lot of the materials we put together today have come from the Florida DOT and the National Center for Transit Research. So I would like to acknowledge them, and again, thank you for being here. What we'd like to cover in our hour today are these three major points. Why should we care as transportation providers, policymakers, people interested in transportation operators? Why should we care about this? And if we are considering using them, that is alternative technologies or alternative fuels, what are some of the factors we need to think about before we start moving in that direction? And lastly, and this will be the second part of the presentation, is how can you compare the potential costs looking forward as to a shift from traditional ultra-low sulfur diesel to some of the other alternatives that we've mentioned here already. What could we expect in the way of costs for fuel and maintenance and so forth of these vehicles? Well, why should we care? This slide takes a look at United States energy use, and you can see that nearly 30% of all the energy, this is all the energy used in the United States, is used in the provision of transportation to create mobility for the people of the country. And when you look on the right, that other pie chart takes that 28% of the total U.S. energy budget and breaks it down into what sorts of fuels are used to move our nation. And you can see the vast majority, 84%, is tied up in petroleum-based, either diesel or gasoline, to make our system go. The others you can see there are natural gas and jet fuel, and jet fuel, essentially kerosene, is also a petroleum-based product. So we're getting into 90% range of what we rely on currently in the U.S. To move our people and goods. When we take a look at the four major economic sectors in the United States and look for the last several years and look at what the projections are out to 2030 in terms of who will be using the petroleum and who is using the petroleum, you can see that transportation continues to currently and is projected to in the future be the largest consumer of petroleum in the U.S. with the electric utilities, that top purple bar or area. Let's see if I can get this pointer to work. You can see that the electric utilities, after the oil crisis of the early and late 70s, began to reduce their dependence on these products to produce electricity pretty significantly. Industry did some as well, and you still have the home heating oil essentially, and commercial applications taking up a small percentage. But again, pretty dramatic picture here in terms of transportation sector and our reliance on petroleum. Now, given that today of all days to be talking about this, given that a significant portion of our petroleum comes from unstable parts of the world, from an energy security standpoint, this should give us cause for concern. But there are plenty of other concerns associated with this heavy reliance as well. This pie just takes the current year of that previous chart. So if we look back at that previous chart of the distribution, and again, that out here we're looking at 2030. But where are we today? Again, 72% of all the petroleum consumed in the U.S. Is used for the movement of people and goods. And as I began to say, given that we have been importing more than we've been producing, We currently are importing about 66% of the petroleum used in the U.S., and a significant portion of that comes from parts of the world that are subject to instability, political unrest, and hence the potential for price volatility. This should be of concern to all of us, particularly those of us involved in transportation policy and in the provision of transportation services. Well, in addition to energy security, obviously there are the environmental concerns that come along with the burning of carbon-based fuels. And this chart that we're showing now shows the total greenhouse gas emissions by those four sectors of the economic activity that we have been looking at: residential, commercial, industrial, and transportation. And while the industrial sector puts out more greenhouse gas emissions than any others, transportation sector is the single largest contributor to CO2. In these numbers are based in metric ton equivalents. So again, energy security, price volatility, environmental concerns, these are all reasons why we feel it's important to pay attention to the development of a broader portfolio of fuels that can be used to fund our mobility. We couple that with what the current fuel efficiency is for our major form of mass transportation currently. I say the most prolific, which is the bus. You can see that while some efficiency gains have been made since 1984, we're still looking at an national average bus efficiency of under 5 miles per gallon, at least according to the APTA data book, most recent one. Couple that with some systems less than ideal load factors and loading and passenger counts for many of the off-peak times that the buses run, and you can see that there's a long way that we need to go to make transit a more fuel efficient and more environmentally friendly mode of transportation. And the shifts have begun to occur. This chart indicates the fleet mix nationally for buses. It does not include paratransit vehicles, but for transit buses in the U.S. and how they're powered. And you can see in 1996 that over 95% of the fleet was diesel powered, and that the introduction and the proliferation of CNG and other LNG vehicles, liquid natural and compressed natural gas vehicles, has been growing pretty steadily. A lot of this is due to the efforts that have been made in California, who I understand retired their last traditionally diesel-fueled bus sometime in the last month or two. But also, you can begin to see the introduction of the electric hybrids and also the introduction of biodiesel starting in the late part of the last decade. So now we're under 69%, at least we were as of 2009, of the municipal and public bus fleets being fueled by traditional diesel. Now, those of you who are attuned to this issue or operators in particular also know that that beginning at the end of 2007, there was the introduction of ultra-low sulfur diesel that was mandated for on-the-road use, and the new vehicles that are being procured are significantly more environmentally friendly than the previous diesel power plants. the fuel that was the ultra-low sulfur fuel that was introduced for on-road, and it's mandated for any on-the-road vehicle. The sulfur content of that fuel went from 500 parts per million to 15 parts per million. And taking the sulfur out of the fuel was not the reason. It's not the reason that you see the cleanup in the emissions profile of the traditional diesel bus, but by reducing that sulfur, it allows the engine manufacturers to treat the emissions in a different way with catalysts and so forth and high temperature devices. Pardon me, that help improve the tailpipe emissions. So that's been a significant improvement for public transportation and for transit buses in particular. I said we needed to talk a little bit about what you might want to think about if you are considering a shift from a traditional diesel bus to some other sort of propulsion fuel or system for your fleet. And the first is, what is it that you're trying to accomplish? What is the policy goal that you're trying to achieve, or goals that you're trying to achieve? Because that could clearly move you in a certain direction as opposed to another. If, for example, noise considerations were an issue, that might lead you to an all-electric vehicle, depending on range issues and the type of service and the type of duty cycle that you were having to operate in. I can tell you that my first foray into alternative fuels really didn't have much to do with environmental concerns as we typically describe them, or an energy security issue. It came from the operator of an international airport where the parking shuttles and the employee shuttles kept fouling the underside of the arrival and departure areas canopies, and they had to be constantly cleaned because of the diesel soot, because of the particulate matter. And we switched the entire fleet of shuttle buses to CNG based, but a strange motivation, but nonetheless it was an important one. Another has to do with fuel availability, and depending on what part of the region you're in, this is going to vary. The cost of the fuel is going to vary also by the part of the country that you happen to be in. We're seeing the introduction of hybrid electric buses that are fueled with E85, 85% ethanol, 15% gasoline. And obviously, if you were close to the source of the production of ethanol in the Midwest, the price of that ethanol is going to be a little less expensive than it would be someplace like here in Florida or in the Northeast. Another good example would be the desire to move to compressed natural gas. And if you're close to a high pressure, high capacity natural gas pipeline, your costs obviously will be significantly affected if you have accessibility to that. Another one that we have a tendency to think about, and this is particularly true for some of the more exotic vehicles, and that's access to the people and the technical backup that you'll need to keep these vehicles running once the warranties have expired. So again, a consideration that you need to think about. Climate is a very important consideration. I noticed in the survey some of you are interested in, and some of you are using biodiesel. The most popular or most used blend of biodiesel these days is an 80% diesel, 20% biodiesel blend, or B20, which is suitable for virtually all climates. But as you start to increase the blends and put more biodiesel in there, there's a tendency for the fuel to gel in extremely cold climates, creating all kinds of issues. So again, something that one needs to think about. Time to fuel is important as well. If you can afford to have your vehicle returned to the maintenance shop or the depot and sit all night and fuel, something like a slow fuel CNG alternative may be okay for you. But if you're having to fuel the buses several times during the course of your operation during the day, that may not be ideal. Also, vehicle range in the duty cycles. We talked about that briefly, and again, there are a few, but some all-electric vehicles where battery capacity limits the range. And again, the duty cycle is coincidental with some of the issues we talked about on fueling time. Another one I'd like to talk about is facility modifications. In a conversion to a fleet to all natural gas, for example, and if your maintenance facilities are enclosed, that's going to require some additional modifications to the shop, ventilation and alarms and that sort of thing. When you get into the exotics like hydrogen and that sort of thing, these can be pretty significant costs that agencies need to consider. And we mentioned this through the whole presentation. That's the cost of the fuel. And when we talk about when we get into the model, we'll be able to talk more about that as well. So the third part of the presentation is, okay, how do I compare? How can I try to predict? How can I try to estimate what this might cost me or my agency if we consider shifting to these alternative fuels? And one way to look at it, the way we've looked at it, are really two metrics. One is the total annualized cost expressed in the dollars per mile that you would spend on a traditionally fueled bus versus what you would spend on a total annualized basis for the alternative buses. This includes all the things you see on this slide. It's the amortization of the vehicle replacement costs, facility mods, the maintenance costs of the vehicles themselves, and so forth. And obviously, the cost-sharing arrangements that you have with the federal government and perhaps your state DOT would play into this decision in terms of what percentage is being contributed by other agencies. Another cost is the total social annualized cost, and what we've tried to do here is and you'll see in the model, is to try and estimate, or allow you to estimate, particularly from an air quality standpoint, what gains or losses are being made by the switch to alternative fuels. And again, this is reported on a dollars per mile basis, and it's a way we'd like to look at this. Now, to do a cost comparison like this, here's a slide that just shows some of the cost information that one would desire. What would the buses cost? When would you introduce them into your fleet? Would you replace them on your if you're running a large 40-foot fleet, 35-foot fleet? You would use roughly a 12-year service life for the things, but you need to know what the fuel economy is for your current fleet versus your future fleet. You need to understand what the life to date labor costs have been for your bus, and guess or estimate what that would be for a hybrid electric bus or a CNG bus or a hydrogen fuel cell bus, and all these other sorts of things. So recognizing that people don't have this information at their disposal, as we began to develop this model, which we're going to talk about it just here in a minute, in order to try and create some default values, because many of you who would like to do these what-if scenarios aren't going to have the time to collect this data and what's good data, what's not. So what we did in the development of this model was survey the transit agencies that you see on this slide, and if there are any of these agencies represented on the webinar today, I'd like to thank you again. And what we were able to do from collecting data from all these agencies is to create a composite fleet so that we could establish some default values for cost comparison. And we got information, all that information you saw on the previous slide in terms of the maintenance costs for the life of the bus, so the fuel costs and the efficiency and the labor costs and the parts costs. We were able to collect on about 5,000 full-size buses from across the U.S. Now, the data are a little old, so there weren't as many hybrid electrics in the fleet as there are today, but still 165 units were on the street at the time, and you can see the numbers of buses that we were able to collect that extensive data on. So what that allowed us to do is then to begin to build this model that we've called the Buffett model. And Cicinio, who I'm going to introduce here in a second, is going to tell you what that what the Buffett stands for. Where I come from in Baltimore, that's a thing that they have at a wedding is a Buffett, but other parts of the world, I guess it's more accurately known as a buffet. But anyway, what I'd like to do now is to turn over this presentation to my colleague Cicinio Conkas, and I guess that Jennifer actually is going to introduce him and talk you through a couple of other procedural things as far as the technical parts of the webinar goes, so to ensure that you'll be able to see everything that Cicinio is going to present. So with that, I'd like to turn the presentation back over to Jennifer Eiley.
Thank you, Steve. Before I introduce Cicinio, I just want to briefly cover how to use the full screen mode in live meeting. Since the remainder of today's webcast is a live demonstration, for most of you, the best way to view the screen is going to be the full screen mode. So here's a normal view of the bottom half of your screen. You can see where the red arrow is pointing to the lower right-hand corner. That is the full screen icon. Here's a close-up shot of it. If you click on this button, it will put you in the full screen mode, and your screen will look something like this, and you will be able to see everything that Cicinio is going to be demonstrating. If you need to exit the full screen mode and go back to normal, you can see here circled in red, you just click on this icon and then click on normal view. And here's a close-up look of it. You can also click the hit your escape button on your keyboard, and that will automatically return you to the normal view. If you need to see copies of these slides again, they are available for download in the handouts section of live meeting, and that's in your upper right corner. It's the icon that looks like 3 sheets of paper. These slides are there along with copies of today's presentation. So with that, I would like to introduce our second presenter for today, Cicinio Conkas. Cicinio is a transportation economist with broad experience in urban and regional economic impact analysis, as well as transportation policy analysis. He currently serves as Senior Research Associate here at CUTR. His research focuses on the linkages between transportation infrastructure investment and economic development. He is the developer of the Bus Fleet Fuel Evaluation Model, or the Buffett model, that he's going to be demonstrating in just a moment. Cicinio is a native of Italy, and he holds a PhD in economics from the University of South Florida with a specialization in urban economics and applied econometrics. So with that, I will turn the time over to Cicinio for the demonstration.
Thank you, Jennifer, and thank you, Steve, for the introduction on these alternative fuels. And I noticed that when we run the poll, there are roughly 40% of the audience that use hybrid electric buses, and the remaining, about 60%, current CNG compressed natural gas users. You also mentioned the acronym of the model, Buffett, and it certainly relates to the Buffett, I guess, meaning in Baltimore, where by buffet, we mean the possibility of choosing among different types of alternative fuels. But buffet stands for Bus Fuels Fleet Evaluation Tool. We tried with this application, which is called as a sketch planning application, to help you, practitioners, at the very initial phases of selection among different alternatives that are available, to select for initial evaluation a subset of alternative fuels for potential implementation in terms of fleet purchase. We, in designing the model, had to strike a balance between ease of use, data availability, and the complexity of the analysis. And as I will show you in just a few minutes, when we run a live version of the model, we think we have achieved this balance, although of course, as in any other sketch planning application, there are trade-offs between complexity of the analysis and the ease of use. And we, as any model developer, we always welcome feedback on the use of the model, and which we have made publicly available, and with a new version which we intend to also put on as a downloadable application through the CUTR website. The model structure, as Steve was going over, the alternative fuel analysis requires a certain amount of inputs, and as we have specified, we gathered information from roughly 30 US transit agencies on about 6,000 vehicles. That provided us with a set of fuel cost inputs, operating costs, and facility, and also other capital costs, to put together a set of default values that are embedded within the sketch planning application. We also stressed the relevance of fuel price variability, especially nowadays, as we have seen, because of our reliance on petrol and in general fossil fuels. Price variability is a relevant component in the assessment of other alternatives, especially when one looks into the future and is trying to guess or understand in a decision-making process if it's really cost feasible to start considering the implementation of alternative fuels for mass transit. Price variability plays a relevant factor. We have embedded in the model a sensitivity analysis module that takes into consideration these wide price fluctuations as one might expect to be happening in the short or medium term. And I'm going to very briefly switch over this NetMeeting application and share the program. So you are going to see the application screen. As Jennifer said, if you have problems in seeing the model itself in your screen, you can put the NetMeeting in full screen mode and scroll right and left using the scroll bar and up and down. When you load the model, which essentially works on in the Microsoft Excel platform, you see a splash screen shot, which is a welcome shot, and immediately the model opens up and presents you with just three buttons. One is run the analysis. You click on it and you start running the analysis. Since we have roughly 20 minutes available, I'm going to just run over a very simple example by clicking on the button. A splash screen will pop up. The analysis consists of 7 simple steps. Given using your input, just going to set up an example of an analysis where I intend to evaluate two alternative fuels, compressed natural gas and the implementation of hybrid electric buses. Of course, the first step of the analysis is to enter some basic information on the scenario analysis that you are running. I'm just going to give a fictitious name to this to the agency name in this case, and I'm just going to call it any agency. And the analysis title, when you run the model, has to be related to your evaluation. In this case, I'm just going to write down CNG and hybrid, which stands for evaluation of these two cases. My initials, and it's relevant to enter at this point the date where you're running the analysis. As Steve said, we have gathered inputs from those 6,000 bases. They are a few years old, but all the costs when you enter the date are immediately reported in the most recent dollar values. So it's relevant that you enter the current date for the analysis. I click down on next, so that I move on the next step of the analysis. Here you have a menu of alternative fuels that can be evaluated, and you can evaluate all alternative fuels by clicking at the bottom where the option to evaluate all fuels, or you can just select those fuels you're interested in to evaluate. I'm just going to select compressed natural gas, and under hybrid, electric, ultra low sulfur diesel. And I'm moving on the next step of the analysis. Here you are asked to enter your current fleet as it stands, and from Steve I got some basic data for a simple example, so I'm just going to enter some representative agency information in terms of current fleet composition. Of course, by default, the model assumes a bus life of 12 years. So as you can see, the numbers, they take you back into time, 12 years back, and on the right side you have the requisition schedule for the upcoming round of purchases, the next 12 years. Anything in this model can be customized, as you will see in the next steps, including the expected bus life. In this case, default value is 12 years. You can, in the process, enter 0 or left the cells empty. The model will interpret that in any given year you have 0 bases, and just concentrate in those cells where you have a certain number of bases and enter the precise number. So I'm just going to fill it up as I'm supposed to, and you can enter a new on the requisition schedule. If your number of bases is increasing with respect to the current fleet that you have, you can enter that information on the right side on the green cells. If you just intend to replace at a certain point in time your fleet when taking into account the 12 years bus life, you can leave that empty. For the example, I'm leaving the requisition schedule as empty, assuming at the end of the bus life I will basically purchase new buses. There's a set of so-called life cycle parameters in the next tab, referring to how much of the capital cost might be shared by the state. And by default value, we're assuming that the state share of the acquisition of buses is 80%. I'm going to leave the default values of the model and accept them. I'm not entering any custom values. If you have better precise information for the analysis you're running, this is the point where you can customize, for example, the bus life expectancy. You can change it from 12 years to any number of years you wish to. We assume, given the database of 6,000 buses and an average of roughly 52,000 miles per year, and when it comes to other assumptions related to fueling facility, for example, if you're investing in CNG and you do not have currently any CNG fueling facility in place, there is an assumption related to how long the fueling facility will last. So I'm going to accept the default values and move on the next step of the analysis, which relates to the bus acquisition costs. Here again, the model gets information from the database. We have default values in terms of unit cost for each one of the buses. As you can see on the left side, the default values, and custom values highlighted by the green cells. You can change the cost of each bus in this step of the analysis. For example, very briefly, I'm showing you that the average cost of the ultra-low sulfur diesel bus is roughly $335,000 as opposed to the cost of a hybrid bus at about $550,000. Also, there are some default values related to the cost of a fueling facility for compressed natural gas. If you already have a CNG facility in place over here, you can enter a 0, which stands you are not going to invest in a new facility. You already have it, so you enter 0 and you override the default value of the model. At this point, I'm assuming that I'm just considering the implementation of CNG. I don't have a facility and I need to build one, so I'm accepting the default values. It's an average cost of building a fueling facility in this case. I'm going to click on Next, which brings me to a screenshot that deals with labor, parts, and some also additional maintenance costs related to the fueling facility. Again, the default values over here that come from the 6,000 buses database, and they are split between labor and parts on a per mile basis. Again, if these are representative of the database of those about 6,000 buses. When you're running the analysis, probably this is the part that you have to pay a little bit of attention in terms of customizing the values, because running costs, maintenance, and operating costs are really a big component of the overall cost on a per mile basis when you annualize it in the evaluation of and comparing different alternatives. So if you have better information, of course you probably have already a database that gives you averages for labor parts on a per mile basis. We suggest to customize the values in this step of the analysis. At this point, just for the sake of the example, I'm accepting the default values and moving to the last step, which relates to the fuel costs. We have some default values in terms of fuel efficiency, miles per gallon. We're assuming the ultra-low sulfur diesel fuel efficiency is about 3.96 miles per gallon as opposed to hybrids 4.05, for example, or compressed natural gas, slightly less efficient on 2.89 miles per gallon. On the right side, there are some default values for fuel costs. Of course, it is really relevant over here when it comes to looking at the fuel costs of the alternative fuels to understand where we obtain the prices. With the arrow of the mouse, I'm going to the right side, and you will see on this screenshot there is a little help icon. If you click over there, we have a prompt that will send you to the most recent list of alternative fuel prices, which are provided by the U.S. Department of Energy Clean Cities alternative fuel prices. It's a report that comes out quarterly, and over there it's where we obtain the prices for CNG, LNG, and biodiesel in general. So if by any chance the model that you download from the CUTR website is not updated to the most recent fuel costs, then you can go and retrieve these the more recent values and enter them in the custom cells. I'm accepting the default values so that we can click on finish, and the analysis is of course I have a very fast machine over here and it's run quite fast. That should happen also on any average PC at this point working with Microsoft Excel. And the results are displayed, a comparison of the costs of ULSD versus CNG and versus the hybrid electric, because those are the alternative fuels that we have selected. This tab basically shows you a summary of the results over the fleet size. And what is of relevance to you is to concentrate on the total annualized cost on a per mile basis of running the traditionally fueled ULSD fleet versus the alternative fuels. Very quickly, I'm scrolling down on the results and show you, for example, that given the default values that we have accepted, for example, and take into consideration that 80% of the cost, the unit cost of each bus will be covered by the state, the cost on a per mile basis of running ULSD is $1.18 versus 1.24 CNG and 1.46 versus hybrid electric, when you of course take into consideration the local share of the costs. If not, if the cost of the bus is not it's fully covered by a single agency, of course the costs are much higher on a per mile basis. Now, two other outputs are relevant at this point. Is the first one, you want to look at the emission impacts, because one of course factor in considering alternative fuels is the emission impact assessment. By clicking on the button emission impacts, basically you're presented with a summary of total emission costs, but also total quantities of emission by major type of pollutant, specifically carbon monoxide, carbon dioxide, CO2, and hydrocarbons, the major pollutants. They are summarized throughout the fleet of buses that you have entered and differentiated by type of emittant. A cost is associated to emitting, so that you can evaluate also on a per mile basis the emission costs, and a comparison is provided at the bottom of the table. We talked about fuel price variability, and which is a relevant component in the analysis. Of course, when you're running the analysis and you're asking yourself, okay, today is February the 24th, and we're just conducting a preliminary analysis of alternative fuels. We're interested in comparing the cost of switching from a traditional diesel-powered fleet to a fleet that consists of alternative fuels. You're looking at today, but you say, we know that prices are going to increase in the short term. How are these fluctuations going to affect the results of our analysis when we really need to make a decision? We have built a sensitivity analysis module that takes into consideration fuel cost variability, and when you click on the button, you're just presented with a prompt, and what the model does basically takes the results of the total annualized cost per mile, takes into consideration short-term fluctuation in prices as forecasted by the annual energy outlook of the Energy Information Administration, and introduces in the model the price variability, so that your results are presented no longer in just in single points estimates, but also in ranges. So basically, and I click on the button OK over here, it's taking just a few seconds to run, and the computation is fairly complex, but it takes just a couple minutes to run, and then you are presented with a set of figures where you can compare the results of the analysis. The objective is to understand how much fluctuation you have around those total annualized costs per mile, those $1.18, for example, for ULSD versus the $1.20 for CNG and $1.58 for the hybrid ULSD. So when you are faced to make a decision that is really a medium to long run decision, you want to take into consideration the variability of the most relevant cost driving factors. In this case, we have seen fuel costs. And you want to be sure, okay, worst case scenario, how much is going to cost us to switch, for example, to CNG? We know that on average, if we were to invest in this technology, it's going to cost us $1.20 per minute. But the worst case scenario could be that the cost on a per mile basis could be as high as $1.54 if we were to encounter a high fuel cost price scenario. So we have provided within this model a way to account for fuel cost variability. And going back to this point on the results tab, remembering the following. I have run an analysis. The model can be run again to consider alternative scenarios, to change some of the default values and enter some custom values. And you can print the results, save them, and rerun the model over and over again to come up with, we call, a portfolio of different strategies. Taking into consideration there are some constraints in the implementation of alternative fuels that go beyond just the cost analysis. Might be that you are so high in a geographical area that it's very difficult for you to implement a given alternative fuel. But this is a starting point. I know we have 5 minutes left. I'm bringing back the presentation to Steve if you have a question related to the model or to the first part of the presentation. Steve?
Thank you, Cecilia. Nice job covering a lot of territory in a little bit of time. What we'd like to do now is open it up for questions and answers. You'll see a Q&A tab up near the top. If you'd like to submit them, we'll do our best to answer them. I will mention, as we're waiting to see if we have any questions, that the emission data that were used in this model came from lots of studies that were done. Some of them were done using different duty cycles, which have a tremendous impact on what the emission profile of a bus will look like. We know that FTA will now be requiring consistent emission testing for new vehicles that go through the Altoona testing. So we'll be able to start to be getting some very consistent emission data, but only as those new units begin to move through. That should help us quite a bit in the future. We have a question here that says, it says, I was interested in finding out the current status of CNG hybrid. Are there any other agencies besides MTS and San Diego operating these types of buses? California, the question was, there are some agencies that are beginning to introduce CNG hybrid electrics. Now, these are a smaller engine, maybe the size of perhaps a V10 pickup truck engine that are used to drive generators and alternators to charge batteries and to run the electric equipment. I've not seen much of those outside of California at this point, although I think they're going to begin to gain some popularity. In California, we've seen E85 hybrid electrics, CNG hybrid electrics, and actually a hydrogen internal combustion engine, not a hydrogen fuel cell, but a hydrogen internal combustion engine hybrid that's being demonstrated. I believe it was at Sunline Transit out there as well. I hope that answered your questions. Another question comes in and asks, has a study been done for passenger van or paratransit use? And we have are beginning to collect data on that type of vehicle here in Florida, and maybe in the future we'll be able to develop that bus model as well, or that vehicle model as well. But currently we've not developed it. And Cicinio, I don't know if you've seen one. I have not.
Not.
Ben asks Cicinio, for the sensitivity analysis, do the histograms reflect the current or projected future price variability?
They take the statistical variance of the current fuel costs. That is, the variability of fuels within ranges is given by the standard deviation around the current mean. So if you have for example, $3 and plus for gasoline, the annual energy outlook short term provides high and low price forecasts. These are taken into consideration within those ranges.
Okay, and I think last question is from Joe, is the latest model available for download? If Cicinio, if you could direct people how to do that, I'm going to turn it back over to Jennifer because I know we're running out of time.
Yes, Steve. We're going to have a link to the download of the model and also the manual that comes with the model. We are going to make it available through the CTR, the National Center for Transit Research website, and to the audience, I will probably get in touch with the staff to provide, I guess, a mass email to so that everybody can get a link to the download. And Jennifer, I think
yes. Great, thank you. If there are any questions that were typed in that we didn't have time for, we'll be sure to follow up with you individually to provide you the answer to that question. So I'd like to thank all of you for joining us today for the webcast. And as a reminder, our next webcast is March 10th, 2011, 2 weeks from today, when our topic will be Trends in Travel Behavior with Steve Polzin. So we hope that all of you will be able to join us for that webcast as well. So we would like to get your feedback and comments about today's program and any suggestions that you have. If you could just take a moment to complete this evaluation, we would really appreciate it. And once again, thanks again to all of you for your attendance and your participation today. And I hope you have a wonderful afternoon. Thank you.